Hello and welcome everyone to this lecture of infinite series. In this lecture, I will introduce you to what is series and what is meant by convergence and divergence. So, let's get started. Before we study what a series is, we need to know what a sequence is. By definition, a sequence is an ordered list of real numbers. So you can take any numbers, but they should be in a particular order. For example, 1, 2, 3, 4 or 2, 4, 6, 8 or 0, half, 1, 1 half, 2, etc. will make a sequence. So now we are ready to define what a series is. The sum of sequence is series. So if we go by our previous example, if we write 1 plus 2 plus 3 plus 4, the sum of this sequence will be called a series. So there is a general way of representing the sequence. The sequence can be represented by summation of un, where n will go from a particular value, say 1, to another value, say 10 or 20. And if this value goes till infinity, the sequence will be called infinite sequence and the series which is formed will be called infinite series. So this is the general representation of series. So it is not always feasible to calculate the infinite series sum. So we calculate the sum up to only the first n terms and we call it the partial sum of the series. So now in terms of the partial sum of the sequence, we define two new terms, convergence and divergence. The convergence and divergence of a series are very important in determining the calculations which can be done on the series. Convergence and divergence are very helpful in statistics, fluid dynamics, and many other fields. So basically convergence and divergence, they give us a basic idea of where we can apply the series or whether we can apply the series or not. Sometimes it happens that you calculate the sum and the sum goes on to a very big number and it is not practically possible to calculate. That is, the series might diverge. So in that case, the concept of divergence comes into play and it tells us beforehand that you will not be able to reach to a particular value and so you may not proceed with the summation of the series. In the same way, convergence tells us a particular value to which the series will go. So in that way, you have a basic idea that whatever you are calculating is reaching to a particular point. So now in mathematical terms, let's define what convergence and divergence is. So if the limit of the partial sum, that was Sn, tending to infinity is giving you a particular value which is finite, then the series is called convergent series and the value of limit which we obtain is the point to which the series will converge. Similarly, if we get the limit to be infinity or minus infinity, then we say that the series is divergent. And in the same way, if the limit is not unique, then we say that the series is oscillatory. This is how we will represent the series mathematically. So now let us proceed with some examples. The first example is in front of your screen. Just try it and pause the video here. So here is the solution. So as we know that the partial sum of this series will be n into n plus 1 by 2, which is the partial sum of first n natural numbers. So when we put this value in limit n tending to infinity Sn, we will get infinite as the answer. Hence we can define that this series is divergent. So here is your next example. Again, try this example and pause the video here. So here is the solution. If we represent the series in form of Sn, so we will get a general term sigma of 1 over n, where n will go from 1 till infinity. And when we put this value in the limit, we will get 0 as the answer, which is a finite quantity, and hence we can say that the series is convergent and it converges to 0. Here is your next example. Try it and pause the video here. So you can see that this is an alternating series. Alternating series is a series where you have alternating positive and negative signs. You can see here the first term is +1, the second term is -1, third term is again +1, fourth term is again -1, and this pattern continues. In the same way, if you calculate the sum of the first term, it will be 1. The second term, 1 minus 1, will give us a 0. If we add the third term, it will give us 1 again. So you can see that the limit is not unique and the sum is different at every step. So hence we can conclude that we are not getting a unique limit, hence the series is oscillatory in nature. That is, it won't go to a particular value, neither it will go till infinity. This was all from this lecture. In the next lecture, we will study about tests which will help us determining whether the series is convergent or divergent. This test will come in handy when we cannot directly calculate whether the series is convergent or divergent.